Hey guys, uh, in this lecture, we're gonna start a new topic, a very exciting and important topic, design patterns. First, let's see what we got. So, design pattern is a very high class topic in software engineering. I mean, if you say that I know the design pattern, and if you say that I have been using it, it's a big, big advantage in the job interviews, right? And also, if you learn it very, deeply, it will help you design software more professionally. So even though it's a little bit hard, so it needs a lot of practice to understand them and to be able to use them in your software. But believe me, if you learn that, it will help you to be a better software designer. All right. So before going further, uh, I'm gonna give you a brief history of how it was initiated, who invented this, in the first place, and I'm sure that this brief history will help you to understand it better. So, brief history about the design pattern. First, tell me what is your feeling about this corridor? If you look at that, what it reminds you. All right. Okay. So it's a little bit scary, right? Yeah. So around 1977, a building architect, Christopher Alexander, which is very famous guy. So this guy, uh, he found out that long corridors like this is very annoying for most of the people. Yeah, it's very scary. You just look at this. Maybe in the Secret Service buildings, we would need something like this. But in the ordinary buildings, it's very annoying. Really, it's annoying, right? So if this is the case, he asked probably himself, so why should we construct such annoying corridors, right? So that was a valid actually question. Then he suggested, okay, so if this is the case, so let's keep the passages short, the corridors and yeah, something like that. And let's make them very room-like. Yeah. So whatever we have in a room, because we usually feel comfortable in the rooms, right? So let's make them room-like as much as possible, right? And if it is possible, put some furniture, bookshelves, and these kind of things that we usually have in the rooms. And also, he suggested that a wide window along one wall will help, will make it a very comfortable corridor. All right. And also, he suggested plenty of sunlight. It makes it very, comfortable and pleasant. Something like this, for example, yeah, or something like this. All right. So just compare this with that annoying corridor. Definitely we prefer this one. Okay. So that's why in 1977 he wrote a book called A Pattern Language, Towns, Buildings, Constructions, right? And he formulated 250 cases like this one in his book. 250 cases. So that's why we call him the founder of the pattern concept. Actually, it was in the construction, but after that, this idea was extended to other majors as well. So the lessons that we learn, from his findings, uh, corridors are everywhere, right? A small house, big buildings, anywhere, hospitals, yeah. So if we can solve a problem in some place, probably that solution can be applicable in other situation as well. So his advice is that we can call it a solution for the corridors problem. It can be used in many, many places. All right. So, in other words, he actually solved a class of problems, not just one problem. Because his solution, as I say, it is applicable to, many others, similar situation as well. Okay. And this concept became the, you know, this, become it's actually became the design pattern, right? So if we have the same similar thing, inside this pattern, then those advices or solution will be applicable. Okay, so here was the brief history about these, patterns in construction. But now let's see how the software engineer learned, what to do. In this section, we want to see how those concepts can be applicable in software engineering. So, what software engineers learn from that book? Okay, so for computer scientists, try to extend the Christopher Alexander's idea to software engineering. These four people are this Swiss computer scientist Eric Gamma. I hope that I can pronounce their name correctly. So the American computer scientist Richard Helm and the Ralph Johnson, again American, and John Vlieside. These people who are famous as the Gang of Four, yeah, Gang of Four or GOF. They after a while they wrote a book, this book, Design Patterns, which is famous as the Gang of Four books or GOF book. Right? So they try to extend that the same idea, and they formulated, I don't know how many, but a lot of design patterns in their book. Okay, so and we will be using some of them, right? Even though they wrote this book, language independently, so actually, they were at that time they were C programmer and probably C++ programmer. But since they are language independent, we can use them as well in any other languages. Okay, so now let's see what is design pattern. Yeah, from the etymology point of view, pattern is not that much unknown to us. It's a regular English word and concept, something that is repeated. Yeah, so we call it a pattern, right? So, but in the computer science definition, what is design pattern? Then we would say design pattern is a proven advice to solve a class of similar problems. It's a proven advice. Look at this. It's not really a solution. It's proven advice that you can use to solve a class of similar problems. After taking some examples later, you will understand better this definition. Okay, so now let me give you some notes before going further. So these design patterns are not finished design. These are some advices. Yeah, you need some elaboration to convert them to code. All right. And also, as I said, they are language independent. And that's the beauty of that. You remember when we were talking about the design phase, we said that theoretically, design a design software, a software that you design, it must be, language independent, right? But in practice, we said, yeah, it will affect when we know that we want to create the software for Java and use it for using Java language. It's a little bit affect definitely. All right, but yeah, so this is the notes we have here. Now let's see what is the design pattern in software. Now, in this section, we want to focus on the design patterns in software. Let's see what we got. So there are a lot of design patterns. Yeah. So I'm gonna just mention some of them here, and very briefly we understand what's going on here. So architectural pattern or high level perspective of the software. All right. And also another type of design pattern is class design pattern, which is, yeah, with respect to the first one, it is lower level perspective of the software. Also, we have enterprise patterns when you want to create an enterprise software. Also, we have game design pattern and etc., etc., etc. We have a lot, right? But you know, those that are on this in the scope of this course is the first two. We will be talking about a little bit about these two architectural and class design patterns, and also keeping your mind that each one of these are divided into several other, smaller branches of the design pattern. Yeah, as we will see in the next slide. Okay, so bottom line, uh, we will be talking about these first two, and also each one of these are divided into a smaller thing, a smaller, patterns. The first group of the design patterns that we are going to talk about is called architectural patterns. What is architectural pattern? So these patterns consider the software as a whole. I mean, this is whatever. So let's say this is a software. So we look at this software at the above, from the above. So and we look at that as a whole, and then we will divide it into the some pieces. So and also not only we divide this into some pieces, but also we need to be able to define that these pieces how they communicate to each other. All right. So based on this explanation, we can call this architectural pattern as the first level of abstraction of the software. All right. So in this, by using them, we organize and we structure our software in a very good shape. All right. So to understand this, what I am talking about, I need to introduce some of them. Then you will see that what's going on here. So first, let me introduce some of the most important ones. So architectural pattern is a general concept. So we have several architectural patterns that I am gonna just introduce a couple of them. So the first one, and probably the most famous one, actually not the most, let's say it's a classical um, architectural pattern, is it's called multi-layer or multi-tier. The second one is really the most famous one, model view controller or MVC. That I put this exclamation mark. That's a very important thing. It's a must know architectural pattern. Also, we have client server, we have peer-to-peer architecture or P2P, service oriented architecture or SOAP, microservices, and so forth. We have a lot, right? And in this course, we will introduce these two, and we leave the rest of them hopefully for the software engineering course. Okay, so now we know what the architectural pattern is, and we know what types of architectural pattern we have. Now let's start with the first one, multi-layer or multi-tier. What is multi-layer architectural pattern? This is a classical architectural pattern, and it was being used, for many, many years, right? So in this architectural pattern, we divide or break the whole system into several layers, several pieces that, layers are the concept and the keyword that we will be using. So each layer could be divided, into smaller layers. But at the, beginning, when we look at the software from the above, so yeah, we will see those layers at the beginning, right? So not only we need to divide, as I said, we need to define, each, the services that each layer can provide to other layers. So it should be a very well defined API, all right? Okay, so this is a very important thing, right? So when you create or when you define a layer, you should be able to define what API this layer is gonna provide to other layers. It should be very well defined, all right? So the more clear you design your code, your software, the better, and it will be more maintainable, definitely. Okay. So here is one example, but this example is important. So in many cases, we divide our application or software into three layers. So this is a widely being used in the software design. So the first layer is called presentation layer, that you are familiar with the GUI or user interface or front end, right? Or view. Yeah, these are all also the other alternative names for the presentation layer. So this is, what is the presentation layer's job is to provide the data to the user and get the data from the user. All right. So the second layer is called, business rules processing layer. We call them controllers or middleware, etc. And also data management layer is the third layer. So data management layer's job is to deal with the data, The data can be database, can be file system, it can be web services, whatever, right? So the data management layer, the job is to provide the data to the rest of the application. Okay. And also, we should design the software in such a way that each layer is only aware of the neighbors, right? Okay, so to explain this, probably the block diagram in next slide will help. Okay, so let me explain everything here. So you see the presentation layer and also the business rule processing layer and the data management layer. And these guys are the users. So, and we have data here. So as you see, data is, separate than the application. So data theoretically uh, it can be on other servers and it can be, totally in separate places. All right. So, uh, what else I can do and I can say here is, for example, this data management layer, its job is to connect to the database and do all of the data retrieval and data updates or insert things. So, all of these are data management's layers job. For example, if in database we need to use SQL to retrieve the data or to manipulate the data, w- you know this layer is not supposed to do that. So this layer does not know anything about the SQL. So if the business rule processing layer needs something, it should communicate to data management layer and say, okay, I need this data, for example. Then the data management layer's job is to create the appropriate SQLs and communicate to the database and get the data and wrap all of the data in an object, let's say Java object, and return it back to the business rule layer. So, so the business rule layer only understand the Java object, nothing else. All right. And also then what would happen? The business rule processing layer send the data to the presentation, and the presentation's job is just to create the GUI and the update the GUI and give the users the ability to communicate with the application. So this is the multi-layer architectural pattern in a very high level description that I gave you. So we have some examples here. Let me show you. For example, operating systems. Operating systems has the same three layers. Actually, operating system is, much uh, more complicated than whatever I want to say here. But in a nutshell, we can say that operating systems have the same three layers. So in the higher level, we have GUI or shells, right? And also in the middle layers, we have uh, the all of the controllers things. So for example, user account management, screen display things, right? And also in the third layer or lower level layer that we call it kernel. In that layer, operating systems deals with the process creation, memory management, task scheduling, and some kind of operations like this. The kernel is very close to the your computer hardware, the drivers, for example, right? So here is how we show the operating system layers. So on the core, on the middle, we have the kernel, and after that we have the controllers layers and the shell, the outer shell of the operating system is just GUI and or the shell that like the bash for example shell or something like that, or Windows command prompt. Yeah. Anyway, so this is the way that they communicate to each other. So GUI communicate with the controller, and controller communicate with the kernel, and the uh, you know the other way around as well. Another example I can take for the multi-layer architecture. Let's divide or break the whole software into 5 layers now, right? So the concept is the same concept. I don't have anything more to add. It totally depends on the size and the type of your application or software. And the number of layers exactly it depends on the application itself. All right. So let me summarize what I said. Yeah, when you uh, divide your software into the some pieces, you need to define what services this block or layer is going to give. So that API is a very important thing. And also, you need to define that how this layer is gonna communicate with the other layer, right? So the beauty of the this multi-layer architecture is that you separate everything into their own layer, right? So it's not the case, for example, the presentation layer jump to communicate to data. No, this is not gonna happen. So, all of these hierarchy, it should be followed exactly. And if you want to, the data is going to give to the persistence layer in this example, of course. Then it goes to the business rule, it goes to the application, and then it goes to the presentation and will be presented for the users. All right. Now let's see, let's summarize what are the advantages of using multi-layer architectural pattern. So first of all, since we are separating the layers and each layer has its own responsibility, so we are following the separation of concern rule, which is a very important in software engineering. Each layer should, have the cohesion feature. So what does it mean? It means that all of the components that layers needs, you should provide inside that layer. So that layer actually is a black box. It you know it's a just look at that. It's a black box that it just provides some services. The second advantage of using multi-layer architecture, architectural pattern, is reducing the dependencies between the layers. So each layer, yeah, communicate with its neighbors, right? It is not the case that, as I said, this layer, communicate with this one. So the dependency is reduced by this. And we are increasing the testability. Why is that? Because when we have some layers, each layer can be tested separately. right? So the testability, the concept of testability will be increased. And uh, when the testability is increased, then the maintainability of the code will be increased. And also we can add the, you know, we can understand the code better. Definitely, this the case. We understand a multi-layer uh, architecture better than the just you have a software here. Uh, you have a bunch of things that they are communicating to each other, right? So definitely we understand uh, multi-layer architectural pattern better. And that's why we say that increasing maintainability in the long term, we will be using um, this feature. In this section, I'm going to talk about the other architectural pattern, which is the most famous one, Model View Controller or MVC. So this is definitely the most popular architectural pattern. And most of the web applications specifically are designed based on this pattern. And as I said, this is a must know, you know, architectural pattern. It's a must know. You need to know that. If you say that you don't know that, you are not considered as a software engineer at all. Okay, so what is this MVC? So it divides the whole application into three main layer. Model, view, controller. Okay, and also like the other architectural patterns, it not only it divide into the layers, yeah, we can consider these as a layers as well. So not only it divides into the some pieces, also it defines the interactions between them as well. Okay, so before going further, let me explain what are these model view controller. So very briefly. So what is model? Model's job is to maintain the data objects. So model, its job is to maintain and manipulate, let's say. Actually, maintain is the better word for that. So the data object. What about the view? The view's job is to maintain the UI's object, user interface. And what is the role of the controller? Oh, the controller is actually the king here. The controller's job is to, uh, you know, they process the user's interactions first, and also its job is to apply the business rules, some validations, some calculations. So in fact, the heart of the application is the controller. Let's say the brain of the application is the controller. Controller's job is to do, the coordination between the model and the view, and also, it manipulate the data and user interface things, right? And the main flow of the applications happens in the controller actually. So that's why I'm saying that controller is the king of the application. So the controller can have several layers itself. It's not the case that we have just one layer of the controller. No, it depends on the size of the application. You can divide the controller in many other layers. All right. For example, the data, if you want to manipulate the data, controller can has its own, the data access layer, for example, something like that. All right. So now let's see how it works. So user interact with the controller. That's a very important part. Users interacts with the controller, and the user sends the commands. What does it mean, the commands? The commands are, for example, user fill out a text box, or it choose a value from a drop down box, right? Or let's say it press a button. So all of these are some commands that the users do, right? And all of these events go to the controller. Everything goes to the controller. So users interacts with the controller means exactly this. And and based on the logic of the application, these commands either goes to the view objects, they update the view objects, or they update the model objects, yeah, whatever. So it depends on that what kind of command it was and what is the logic behind the application. So the controller can do all of these stuff, and then if the view was changed, the user can see the changes. Or if the model is changed, then the model notifies the view, it updates the view objects, and the view go to it will be displayed on your user interface and can be seen by the user. Let me show you all of this explanation visually in the next slide. So here is the uh, view controller and model as you see here, and that's our user guy. So what happens here? This is the, all of these three, look at that. All of these three are inside your application, all right? Okay, so first user interacts with the controller, as we said, and controller has two possibilities. Either it doesn't need to go to the model. So maybe it is something, some validation or some calculations that it can go directly to the view object, and the view object, when it is changed, then the user can see all of those changes. Uh, Here I need to explain something. So this view, as I said, is actually it's an object. It's a view object. All right. So this view object will be created by the controller. And let's say that controller create an HTML file. And this HTML file goes to the user, actually not directly to user. Let's say we have the browser here. So let's say this is the browser, right? Uh, so this view goes to the browser, and browser will render that HTML file, and user can see that. Okay, all right. So we were talking about the controller. So the controller, either it doesn't need to communicate with the model, so it calculates something or validates something, and it updates the view, and view goes to the browser, and browser will render all of those changes. Or in other situations, controller needs to talk to the model and create it, or um, update the model. And also we design the code in such a way that the model can notify the changes to the views. Okay, so this is how it works. Um Before going to the next slide, I want maybe you ask, okay, where is the data here? Yeah, the main data, the where, the place that we maintain the real data. The model is just an object. right? So the real data is here. Yeah, it can be, let's say it can be database, or it can be just flat files, right? Whatever it is, the controller's job is to communicate with the data and get the data and create these model objects, all right? So, um, so that's why I said that controller can have several layers by itself. For example, one layer of that is, its job is to communicate with the database, or communicate with the flat files or file systems, or you know web services. Yeah. Anyway, so here was how the MVC, or model view controller, works. Okay, so some question and answer. So these questions are very important. Usually they were asked in the previous semester. So do users interact with the view or with the controller? Yeah, with the controller. The view actually, whatever you see, the text box, the buttons, and those kind of things, all of them are dumb um, toolkits, let's say, components, very dumb components. So when you fill out a text field, that text field should go to the controller, and controller decide what to do. So do users interact with the view or control? Yeah, definitely controller. Definitely the controller. So the controller's job is to decide what to do with that data that comes from let's say, the browser, for example. If you push on the bottom, a button, right? So if you push on this will be sent to the controller as an event. And in the controller, as you know, in the GUI programming, we saw that. So you have a piece of code that is a listener to that button, and that piece of code will be activated and will be run. So you see, everything is on the controller. Remember that. Another question can be asked here, the model connect to the database? No, the model is just an object. It's some objects, right? Again, controller is the king. Yeah. So, so the controller will bring everything from the database, and the model's job is, they are a bunch of objects. Yeah, and their job is to connect to the view objects. So these are the view objects, and these are, let's say, the model objects, right? So they just carry some data. And when I say object, um, do you understand what I mean, right? It's a Java object. It's just a pure Java object. We call it Pojo, plain old Java object. All right. So the king is the controller. All right. So this is whatever you need to keep in your mind. All right. So here is another example to show you that we can have multiple views from the same data. So here we have, let's say, a pie chart or a chart or something. Here we have another kind of view. So let's say a tabular data. Yeah. So the user will interact again with the controller. Controller, uh, you know, update or create the model data, and the model will be, notifies all of the views that are uh, bound to this model, and all of them will be updated at the same time, and user can see them. So probably the best example for this kind of multiple view is Microsoft Excel. You know that you can have a table, and then based on the table you can create many charts, right? Uh, and when you change the table data, all of them will be updated at the same time. So that's a good example for this kind of multiple view, right? All right, so now let's see what are the advantages of the MVC. So first of all, it has all of the advantages of the multi-layer architectural pattern. We mentioned them before, but let's see what were them. So satisfying the rule of the separation of concern, you remember that? Reducing the dependency between the layers, and also increasing the testability because we have separate layers. Each layer can be tested separately, and also we said that we increase the maintainability of the software. So all of them will be applicable for the MVC as well, because MVC is somehow multi-tier or multi-layer architectural pattern. All right. Okay. So uh, the only thing that I want to add here, and the creator of the MVC usually are proud of it, is this: users of the application cannot manipulate the data directly. So actually, we can say the same thing for the multi-layer architectural pattern as well, but this feature was in the mind of the creator of the MVC. So when we are talking about the MVC, just keep in your mind that the one of the most important feature of that is users cannot directly manipulate the data, and everything should go through the controller. All right. Now let's see, if we don't use architectural patterns, what would happen? So here is what would happen. So you designed your code, your software, and you would say, okay, I have these 6 classes, let's say. And then you say, okay, so these are the dependencies between these classes. After a couple of weeks, you would say, oh, no, no, you know what? Yeah, there are more dependencies. And then, a couple of weeks later, probably you would say, oh, there is another dependency like this. So what is this? Yeah, that's what would happen if you don't use architectural pattern. So first you need to divide your code, your software into some layers first, right? And then each layers will be independent, right? Uh, so do you see any similarity between this code and this bubble of the spaghetti? Yeah, they are very similar, right? That's why we call this kind of design, horrible design, as a spaghetti code or a spaghetti design. All right, so that's what I have for this lecture. See you guys in the next lecture.